Good morning, everyone. Today we will be continuing with our discussion on Module 1 Analytical Chemistry through our next topic in that module, that is accuracy and precision. Before understanding what do you mean by accuracy and precision, let's look into its opposite term, and that is error. Now, what do you mean by error? Error can be defined as the numerical difference between a measured value and the absolute or true or the ideal value of an analytical determination. You know about this term, that is measured value, that is the measurement that you make in an analytical determination, but you might not be aware of these terms, though they are self-explanatory. They are very absolute or true value. These mean that there can be no more accurate than the value that is said to be absolute or true. But we know that such things can never exist. Therefore, an absolute or a true value for any analytical determination can be considered as ideal value. Now, if that is the case, then how we can define error? Because error cannot be defined only in terms of measured value. We require a reference. So for that purpose, we actually define these in terms of accepted value. That is, a value that is accepted to be a true or an ideal value for an analytical determination. So from here onwards, whenever I'm talking about the error, I'll be talking about the accepted value. Now, how do we report errors in a scientific report? There are two ways. One is the absolute error, another is the relative error. The formulas are self-explanatory. As you can see, absolute error can be equal to xi minus xt, where xi is the measured value and the xt is the accepted value. Now, if you want to calculate the relative error, you need to divide the absolute error with xt, that is your accepted value. This relative error can also be expressed in terms of percentage or as parts per thousand. For doing that, what you just need to do is you have to if you want to express it in terms of percentage, you have to multiply ER with 100. However, if you want to express it in terms of parts per thousand, then you have to multiply ER with 1000. So these are the two ways in which you can represent relative error, either as percentage or as PPT or part per thousand. Let's look into numerical. So in this numerical, you can see a set of electronic charge measurements are being made, and there are 6 measurements being reported of electronic charge. So it is 4.79 into 10 to the power of minus 10. All these are superscripts. Somehow it didn't come in the slides. So there are 6 measurements being made here, and we are asked to calculate the absolute error as well as the relative error in terms of percentage. We are given the accepted value of the electronic charge as 4.8 into 10 to the power of minus 10 ESU. Now, just by looking at this problem, we are given measurements, we are given the accepted value. So that means it is easy to calculate the absolute error. But here, since we are given many measurements, we first need to calculate the average value. So there are 6 electronic charge measurements. So we calculated the average and it came out to be 4.798 into 10 to the power of minus 10 ESU. Now the absolute error, which is numerically equal to xi minus xt, would be this value multiplied by the accepted value, and it comes out to be minus 0.002 into 10 to the power of minus 10 ESU. Now, if you remember the significant figures, we have to report the final value to the least number of decimal places. So it is only one decimal place that is the least decimal places available in the ones that are used for subtraction here. But if you reduce this to just one decimal place here, then this would be 0.0. That will have no meaning. So that is why in the final results we are keeping one significant figures at least to show the value. Then relative error in terms of percentage would be simply absolute error divided by the accepted value multiplied by 100. So when we do that, these terms will get cancelled and we get the value like this. And since the minimum number of significant figures is 1 here, so we can report the final value as minus 0.04 ESU. So this is how you have to calculate the absolute error or the percentage relative error in any of the given topics that you are asked to, in any of the problems that you are given. Now, let us go, I'll just give you the terminologies or the types of errors that are reported in a scientific measurements. So broadly, these errors can be classified into two types. One is determinate error and another is indeterminate error. Now, as the name suggests, determinate error, here we can determine the source, or in other words, source is known in this case. So here, whenever the errors are such that we are able to know from where that error is coming, then we classify them under the category of determinate error. However, indeterminate error are the one where we are unaware of the source from which this is coming. So these are pretty much the errors which we usually are not able to correct or avoid in most of the scientific experiments. Determinate error can be further classified on the basis of their source or on the basis of their sample size. On the basis of their source, we can classify them as instrument error, we can classify them as method error, we can classify them as personal error. So these terms are very much self-explanatory, though we will be going into the details of each of these in the next section of our class. Further, they can also be classified on terms of sample size as constant error or the proportional error, where one is independent of the sample size, and in the second case, it is dependent on the sample size. So we will go into the details of each of these errors in the next class. Till that time, just go through this topic, and while we meet for the live session, we can discuss this particular topic in details. Thank you very much for your attention.